Hello, and welcome to Debugging Downtime. I'm your host, Z. Spencer. In today's episode, Betsy, Jackson, and I explore whether Sidekiq could be responsible for Notabli's recurring downtime. We discovered a number of long-running jobs that perform writes to the database. This aligns with the Amazon RDS database getting overwhelmed by writes and causing locking. To attempt to resolve this downtime, we come up with two hypotheses. First, we adjust the Sidekiq unique jobs configuration. Right now, it lets new jobs be created even if that job is still running. Second, we reduce the number of connections and workers available to Sidekiq. This slows down the processing of parallel jobs, giving the web application more breathing room. If you find this episode helpful, remember that Debugging Downtime is 100% funded by viewers like you. As we reach funding milestones, we'll tighten up our recordings and expand on these diamonds in the rough. Season Pass holders get all future updates for free. So what are you waiting for? Buy your Season Pass today at wecohere.com.
Notabli focuses on secure, private data share, social networking among families. So instead of having Facebook try to sell you ads because they're creeping on your kids' pictures, you can just share them with their aunt and not have to worry.
So,
one thing I appreciate about
this is all very lovely. I just realized I was not recording. So we're gonna have to start over.
That's okay because we're not a nonprofit.
Yeah,
And
they're just not making any money, which is different.
Yes, we are a not profiting company yet. But that's cool.
All right, so I'll start over again. We'll have to do a couple claps. And we'll do circle of appreciation, me to Betsy, Betsy to Jackson, Jackson to me, and then go from there. All right, so let's do a couple claps. 3, 2, 1, clap. One more. 3, 2, 1, clap. Beautiful. All right, so now we're really getting started. Welcome everyone who is potentially watching in the future and watching in the present. Today we are working once again to try and figure out why Notabli is going down and how to, keep it coming back up again. Today we have 3 participants, and I will be introducing Betsy Habel. Betsy is a co-founder of Cohere, the consulting and education and training company that we co-founded, which is redundant, but whatever. And one of the things I really appreciate about her is she, last week, helped us navigate some really complicated and nuanced intellectual property assignment. And she did absolutely wonderfully, and it was super great. And I really, really respect and appreciate that. So, Betsy, how about you introduce Jackson?
Yeah, I'm Betsy, and I'm going to be introducing Jackson Latka. Jackson is the co-founder of Notabli, a social network for families. Notabli, unlike Facebook, believes in providing value for money and maintaining user privacy. So instead of creeping on your kids' photos to sell you ads, you can, and expecting Facebook to use them to sell you ads, you can just share them with their aunt and uncle, and everyone can have a nice time and not have to have a faint big brothery feeling in the back of their skull. One thing I appreciate about Jackson is the good humor and analysis that he put into helping Cohere produce this video series. He's been very actively present as someone who wants to make it work rather than just someone who's kind of along for the ride as we do this experiment.
Awesome. Thank you so much, Betsy. So I'm slightly under the weather, Jackson, and I'm excited to introduce Z. Spencer. Z is also a co-founder at Cohere. And Z is a new friend of mine and someone who I admire for his ability to essentially take really complex problems and talk through them and tell you what he's thinking, which makes him perfect for doing this type of video session. So thanks for including me, and thanks for including Notabli, and excited to dive in.
All right. Well, that is a wonderful introduction. So let's kind of hop in. So setting the stage. Notabli has been experiencing since Christmas of 2018 downtime issues where their servers will fall over and not get back up again. So day after Christmas, I joined Jackson and Jackson's other engineering helper to figure out why it was falling over and try and bring it back up. It turned out the Amazon RDS instance was just running out of operations, and it was causing the entire system to overqueue and fall over. So we isolated that, expanded the disk size on the RDS instance, and that gives you more write operations and read operations, and then relaunched the RDS instance. And we were hoping that that would be enough, but it turns out the something in the Notabli architecture is essentially DDOSing the AWS RDS instance. So there's a bunch of connections that get created, and then just a pile of writes that get flung at the database until it pukes and falls over, and then the entire system goes down. So people who are trying to upload that beautiful picture of their nephew taking their first steps, or their niece ballet concert, or vice versa, can't actually do that anymore. And as you can imagine, that makes Notabli's value proposition pretty stilted. So last session, Betsy and I and Jackson dove pretty deeply into the JSON representers system to try and figure out JSON API resources system. Sorry about that. To figure out if just maybe, that was the thing that was bringing it all down. We decided it wasn't, and then thought, well, maybe it's this SNS background job that keeps failing, and we submitted a very small patch to stop the background job from re-firing itself. And unfortunately, that did not solve the problem. So for the last couple weeks, Jackson has been waking up at 3 a.m, rebooting RDS, going back to sleep, and so on and so forth. And he has got this amazing log file that we're going to kind of review together. And I'm going to ask him to kind of take it away, and then Betsy will be asking really good questions, and I will try to do the same.
Cool. Thank you so much, Z. So at the top here, I just kind of recap. I think everyone could see this screen, right?
Yep.
Not my screen, but a screen. Okay. So this activity notifier job is what we focused on, which was an Amazon SNS, which we use for push notifications. So in our Sidekiq jobs, we noticed that these retries were happening over and over and over for SNS, and thought that might be making excessive writes to the database. But as Z mentioned, turns out that wasn't at least the full issue here. So that was January 15th. That evening on January 15th, we already saw more H12 errors from Heroku. And when I checked into Sidekiq retries during my database song and dance reboot, I found that there were 7 items, and 5 of these were SNS related. And my thinking at that time was that maybe those predated this patch, and that those were still just hanging out. So I killed those, which means I could restart them later if necessary, and otherwise just logged the paper trail note at that time. When I did that, I noticed that there was a lot of these Puma worker killer tasks hanging out, and we were getting these OOM, these out of memory issues, just rapid fire. So that was my note at that time. Then the next kind of real big chunk of intel, I think, is January 17th. This happened again. There were no SNS activities, so maybe that theory was correct. They didn't show up again. But I did notice that Airbreak was telling us that this intercom job was getting a 401. And so during the next few days of issues, during these H12 timeouts, I noticed that intercom job would often be present within a short window of right preceding that time. And so the concept of theory was that that was the issue, or that is least related to the issue and stacking on top of other issues. So Ty, one of our engineers that's helping out, jumped in and disabled that intercom job. Let's see, that was disabled on the 21st.
Yeah.
And even just shortly after that, we noticed that, there was still those intercom jobs showing up. So I don't know why they were still showing up, but I have to say since then that the timeouts have been less frequent, and when they happen, less severe. So I haven't started the database much in the past 5 days. and we could jump into the Heroku logs or the metrics and look at the past 7 days. But there's something happening around like 12 to 2 a.m. UTC that is still happening then. And before I kind of turn it back over, I just want to, I dropped a couple of other ideas in here for background job issues. And one of those, I noticed that on the 24th of December, right around when we first started having this big wave of issues, our email digest stopped sending. And sometimes that's due to our unique jobs container filling up. And so every once in a while we clear those out. And so I just wanted to throw that in here. I don't know if it's correlated closely or loosely or at all, but but something else that we could look into. And I just cleared those unique jobs last night. So hopefully around 2 o'clock today, these email digest batch gets sent out again.
Great. And now that you've said that, Jackson, I'd like to kind of start again from the top. I didn't want to interrupt your narration of things because it was pretty important to me to hear things in your own words first, rather than asking leading questions that might nudge you out of your initial intuitions, because you're the person who has been working with the system. So now that I've heard that brain dump, I'd love to go back to the top and kind of echo back what I heard you saying, along with some of the thoughts that were popping up in my head while that was happening. This is both to expose those for our viewers and also to give you an opportunity to correct me when I'm wrong, offer additional information that might relate to what I'm observing or wondering about, etc.
Excellent.
So starting out, what I know going in is what we knew last week. We knew that there was a database issue. We knew that we were experiencing database activity spikes in terms of raw number of input-output operations, which I will henceforth be referring to as IOPS because I can actually say that. And we don't have a good idea of the balance of whether those are reads or writes, but we suspect that it's both, and that it's the fact that a lot of reads and a lot of writes are both hitting at once is the ultimate cause of the issue. We were hoping that those large numbers of reads and writes were mostly triggered by the activity update notifier, which needs to do a lot of pretty intense reads in order to determine who to notify as of this moment. Last week, we thought about trying to optimize that, but we instead just decided to silence certain kinds of errors so that we wouldn't trigger as many retries and crash the database as it frantically tried to send Android notifications. That was insufficient. Right now, the H12 started popping up again. They again appeared to be related to IOPS spikes. Z, can you scroll down a little bit less fast?
Oh, sorry.
Thank you. Still on January 15th, please.
Oh.
That was just me bringing us up to January 15th and summarizing what I knew going into Jackson talking about that.
Can we try and shift to a more conversational style for this part? Because I feel like we spent a lot of time narrating, and it's at 1:15. So I'd like us to have some back and forth a bit. So maybe pose some questions. We all have the document. Jackson's explained some things. I don't think we need to rephrase everything, right? So what are you curious about? What are you thinking, right? What do you need information on to orient yourself towards solving the problem? I think that'll be a little bit more productive.
Yeah. So we have a recurrence of the issue. So what we did clearly didn't fix it. It's hard for me to tell based on the fact that a different issue seems to be appearing right now, whether it's honestly and authentically a different issue or just something that had always been a problem, but we previously hadn't been able to see because of all the other stuff that was going on. What's fascinating to me is that you would think that the intercom issues that we're seeing would have been popping up in parallel to the SNS errors we were seeing before.
Why do you say
that?
So
I'm wondering. SNS is an external service. Intercom is an external service. SNS and Intercom are run by different providers and theoretically have different sets of infrastructure issues. And so unless those two code paths are somehow coupled to each other, which is possible but would seem very odd to me.
What could we look at? So it sounds like one of the possibilities that when we start diving in, we might want to look into how the background jobs, like maybe there's an application job class that has some stuff that's writing and reading from the database that, you know, cascades down, maybe. I don't know. Because there might be some shared code between them, right? I think you're correct. There's probably some shared code between them. And maybe if we look into, maybe that's a thing that we can dive into when we actually start jumping into code. Jackson, what are you thinking about that? Does it sound like the diversity of jobs causing the issues is worth looking into?
Yes, I can confirm that the intercom error is nothing new that's come up. Like that's an existing issue. So it's nothing we caused or changed, that's for sure. And it's nothing that is new. There's like many air brake instances of it. I mean, my general theory is that these things, if they are related, are stacking up and causing it to tip over. And I don't think it's like intercom issue or a SNS issue. I think it's the way we're handling them.
Got it.
Yeah.
So what I'm hearing from that is it was always there. It suddenly turned from the second worst problem to the worst problem when we knocked off the first worst problem.
Maybe. I think we knocked off a problem
Yeah.
in a series of issues without prioritization.
So
out-of-memory errors are also really interesting to me because those are going to trigger process restarts, and that's not going to make your timeouts nicer.
Yeah, so the Puma Worker Killer, is that also a background job, or how is that configured in your application? Or we can also dive into the code if we want.
I don't know the answer to that.
Okay, so that's the thing we want to think
I
about.
want to double-check our understanding, but my first guess is that Puma Worker Killer operates pretty similarly to Unicorn Worker Killer. Puma is a Ruby rack-based web server like Unicorn. Unicorn Worker Killer looks at the amount of memory each Unicorn process is consuming. And once it hits a defined memory limit, it assumes that your memory leaks have gotten too bad to let the process keep on going, so it terminates it. And the expectation is that your load balancer will spin up a new process to replace it. So that would be something that was happening at request time. I don't think it's related to the jobs problem, but I think that, again, we're probably dealing with several different issues all happening at once.
Jackson, you just added that line. Why did you just add that line, and what were you thinking when you did it?
Well, it was missing information that when I saw this Puma Worker Killer and these out-of-memory errors, we floated this in the Slack channel and decided to reduce the concurrency, which I have no idea what that means. But we reduced the concurrency from 6 to 4. So that's another variable in this equation.
Did you see the Puma Worker Killer going out of control since you've done that, or have we tamed the tiger, so to speak? Good question. I'm not sure.
Okay. I think it's that's something we should keep in our back pocket because memory, to me, that kind of continuous hitting Puma Worker Killer errors signals a memory leak. And that memory leak is not going to go away without active remediation. I don't think it's the highest priority thing to look into today because my assumption is that if there's a memory leak problem, it's going to be a fairly different problem than the worker problems we've already been looking at. So while they're probably compounding each other, I think we're going to make better use of time by focusing on the problems we already have kind of a handle on.
Okay. So what I'm hearing is we have a couple different paths to go down. So one of the paths is we can kind of look for commonalities in the jobs queue to figure out, okay, as we write these, there was, what was it called, Betsy? The thing about, there was something about a jobs item potent or something. Unique jobs, this unique jobs stuff.
Unique job.
So it feels to me like it's possible that unique jobs, is the intercom job also a unique job?
I don't think so.
Know.
I don't believe so.
Okay. So one of the paths is to kind of dive down into this unique job stuff. Another path would be to kind of look at Puma Worker Killer, but we don't think that's a really good idea because it doesn't seem like it would. It seems like it's a pretty significant shift from where we've been looking, and it's also a thing that is it's unlikely to be a significant part of the problem because we're seeing the jobs doing things.
Yes.
Jackson.
One related question to the Puma worker, Puma killer is the idea that we are not seeing our memory cap out in Heroku, yet the Puma worker killer is jumping in and killing out of memory issues.
Oh, that's really interesting. Thank you for bringing that up.
Okay.
I don't think it changes my assessment of not thinking that Puma Worker Killer is a great use of time today. But I'm going to take some time between. Oh God, I'm hoping we can fix. I'm hoping we can fix the worst of everything today. Realistically, I'm also going to take some time between now and our next session to noodle on why that might be, so that I can hit the ground running with that, or just give you that feedback out of hand, because that's weird.
All right, so we are 25% into. So I would like us to shift into code and pick one. And I think the decision sounds like we're going to investigate the background jobs and look for commonalities, where there may be writes or reads that are pretty extensive in some of these jobs. So my gut says that we want to jump to Sidekiq first, and then kind of like get our orientation around what jobs there are that are being called, and then step back and make another decision. Does that sound reasonable?
That sounds great to me. I do want to reinforce for viewers that this is not because I think this is the actual root cause. I think the actual root cause is probably either non-performant reads or insufficient batching around jobs. But those are going to be really significant architectural issues that we are not going to have time to dig into adequately in the next hour and a half. So what we're going to do is we're going to look at ways of ameliorating the background job problem to clear space for slightly less pressured look at the underlying architectural concerns.
All right, I totally forgot to. Oh, it's Adam.
Yeah.
Open the code editor. Let's move this to the right window. Move to workspace 3. That feels good to me. And let's start with. How do we get to the Sidekiq queue, Jackson?
It is Notabli core. Do you want the address?
It's notablycore.herokuapp.
Notably-core.herokuapp.com/sidekiq.
And then
I dropped those to you. Yeah.
Oh, in Slack?
Yeah, in Slack. I could resend them. That's helpful.
Yeah. So let's.
It's Notabli admin, and I'll drop the password to you.
Okay.
I can also screen and I turn his password security, so be the one who copy and pastes in, and that might be more secure.
I've got a second monitor that.
Cool, thank you.
Notably -admin or notably one word admin?
One word.
Copy. Paste. Never. No saves. All right. Cool. So, Betsy, I'm going to hand off keys to you, and I'll let you just kind of follow your heart, and I'll ask you questions and try and figure out what the heck is going on. And if you want, we can try and go through a different route to kind of start getting our hands around these jobs. It's up to you.
Yeah. So just reiterating the interesting dates. The interesting dates are the 15th, the 17th, and the 19th, right?
That sounds correct to me, Jackson.
Yes. Those are 3 of them.
Great. So this looks like possibly around the 15th. That's the 14th. So jumping jobs on the 14th, but nothing particularly interesting or spiky looking on the 15th. Am I looking at the correct graph?
Yeah, this should... Sorry.
That's just the number of jobs, right?
Yeah. So there's no excessive job activity. I'm seeing a dip on the 23rd. Was this related to turning intercom sync off, Jackson? Or...
Let's see.
But it's a really...
No, that's I think that might be a database reboot, potentially.
Got it.
Okay, so...
But if we pop into like the retries or the dead. Okay, so that looks like one that one doesn't typically fail, so that one must have just been something off. But the dead, these are the ones that were showing up before.
And so we see storybook generator job again as one of our problems. And that's interesting.
Potentially. Although I think what's happening potentially there is that when these fail, it's because there's like a bad asset that's trying to be added to a photo book. So that happens occasionally, but it's not a recurring issue as far as I've seen.
Yeah. What's interesting to me about these is that my guess is that they're probably really expensive in terms of number of reads they need to perform.
Mm-hmm.
And so since they do have this potential for bad assets, when they do fail, it's a big deal. Mm-hmm. I don't think that a single one is likely to take the entire database down with it, though. So I think that the intercom sync jobs are still a higher priority, especially given that disabling them did lead to a significant decrease in errors. Like that's very, that's useful information.
Yeah. The question that popped up around intercom was, are we really writing that much, or are we just reading a lot? And I know we have to write back to intercom, but I think it's more of an informational like pull instead of push.
Yeah. I think next I would like to actually look at what the intercom sync job is doing, because that's the thing we know most about potentially being a problem right now. But what I'm seeing here isn't any kind of weird Sidekiq stuff at any of the interesting points other than the big database reboot. And so that makes me wonder what I'm missing about the intercom job that makes it such a problem. Z, do you have any thoughts?
My gut says that because this is happening with a lot of jobs, and because there is the Sidekiq plugin that gives you these uniqueness features for jobs, that it's entirely possible that what we are seeing is jobs having some default behavior that is invisible, that includes writing to the database essentially. So even if we fix a lot of these, my gut says that if there's, so like if we look at, so let's say we look at Heroku's like scheduler, right? And there's something that happens at 10 UTC or 22 UTC that it keeps kind of falling over. Like we start enqueuing something, right? And that thing that we're enqueuing is for some reason doing a bunch of writes and reads, regardless of why, and then that starts slowing other things down, and stuff, it just starts compounding and compounding, and so the jobs kind of like DDoS itself. And that also kind of matches what we're seeing, where the DB instances are, if we look at the connections are spiking at random times as well. So let's go to monitoring. Yeah.
Yeah. CPU utilization is all over the place, but we don't think that that's the problem. Connections, we're pretty steady.
Check your date range. This looks really like a short period of time.
Yeah, that's fair. Last hour, lol. Yep. Let's try last 2 weeks, which isn't going to catch everything. Or no, that is going to catch everything.
Yeah, look at these. So you scooped past the DB connections one. So look at how the DB connections has a recurring spike. And oops, the time range shifted back down again because computers. Yeah. So these DB connection spikes. And
my guess is that it might be Sidekiq. It might actually be the Puma worker killers. Because when the process reinitializes, you're going to be making a lot of new connections. And so that might be where the Puma issue kind of comes in as a compounding factor.
And every time we cross over about 80 connections, that's when we get H12s and the issue starts.
Got it.
182. That's how many connections you need.
Sidekiq. Sidekiq uses connection pooling, I'm pretty sure. I would be shocked if it didn't, but I don't actually know that.
We can ask the Googles.
Yeah. I remember doing research for this and HTTP connection pooling at a while. I think that Sidekiq has good.
Maybe the wiki that's just below it seems more viable to me. All right, so what we're looking for connection? All right, cool.
One Sidekiq process creates 10 threads. If that's crushing your machine with I/O, you can adjust it down. But we've already done that. I mean, we haven't.
Have we?
No, we have not. We have reduced the number of processes. We have not reduced the number of threads per process. So that's an interesting variable to fiddle.
Yeah, and it also seems like there's a relationship between the threads and the connection pool. So we might want to add this to our queue of things to investigate, which is is there a pool setting in our production database.yaml? And if not, maybe we want to.
So one thing that I do know was true about Sidekiq at least 2 years ago when I was looking into this for HTTP connection pooling problems is that the connection pool is shared across threads. It is not a connection pool per thread.
That makes sense.
Yeah, I do think that the connection pool being too large and this creating swarming issues is a likely. It's a knob we could twiddle quickly. I still think that Z's instinct about unique jobs creating other issues is a really good one. So I'd like to look into that more in the hope that we can get something that's a little bit less brute forcey of a solution. But if we can't, then I think that throttling here would be a great next step for, oh God, at least just make it go away.
Yeah, so I've got that on my list of the next thing to look at, and probably around 2:30, I will prompt us to switch to adjusting the connection pool settings.
Z, could I add one thing to your list for now or later?
Sure.
That would be that I'm looking at our Heroku scheduler jobs, and at 0 UTC, that's when we do a rake of story subscriptions, which are everyone who has a photo book subscription. That's when we go through and pull all that information into their books. And when I look at the 7 day, and so that I think that's also bad a bad time to set that job because 0 UTC is probably like, that's our highest throughput as well. Around, it's like 8 p.m. Eastern, right?
Yeah, that is a pretty bad time. So we've got a couple different things to investigate then. Once we've spent, let's spend the next 25 minutes on the our jobs, writing aggressively but silently, and then if that is not the case, we'll switch to connection pool, and then we will look into the storybook, and we can also adjust the Heroku scheduler to change the storybook to say 8 a.m. UTC as a possible solution.
Another thing I might want to look at, given the just complete, like on this graph, the spikes in IAPS are just kind of all nothing, 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 bang, nothing, 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 bam, in ways that appear to be loosely connected to when the outages have been experienced. But you've also been saying that it's just been kind of cranky. So the fact that there are spikes at points you didn't specifically narrate isn't a concern to me.
These IOPS spikes?
Yeah.
So these are 100% correlated with H12s and downtime. And these right here towards the end, like these are probably when, I mean, we're zoomed way out, of course. So like there's a lot of normal activity at the bottom. But these smaller spikes, I'm assuming, are kind of when we were able to, almost like when the app self-recovered.
Yeah. One thing that I'm interested in like the severity of these spikes, given the Puma worker killer issues, is, are there cases where there's a lot of reads or writes on app startup too? That's another thing that could potentially be an issue. It's not an issue I want to investigate now. It's an issue I want to say out loud so that I remember it as something we can investigate in the future.
Cool. I've added that to after the storybook scheduler.
Cool. All right. So let's look at what Unique Job is doing. First question is, where is Unique Job? Is Unique Job coming from a gem, or is it an internally made class? Do we have an application job class, first off? It doesn't appear that we do. So we all have, looks like everything is including Sidekiq worker, and there isn't necessarily other stuff. You said that emails were an example of a unique job, Jackson?
I believe so. Or they get locked up.
I'm going to close out the side windows because it's just too tiny.
Thank you.
Either they are a unique job or they get blocked somehow by unique jobs building up.
And that's email, neither email password reset looks like it, nor email welcome looks like it encompasses the behavior you were talking about earlier.
Those both get blocked up as well, but what I'm referring to is email digest mailer job.
Thank you. That's why I wasn't seeing it as something prefixed with email. Include active to serializable. That's interesting. I am wondering, so when I see the name of that, my guess as to what it is likeliest to do is serialize active record objects and other objects, but active record objects are the ones I'm concerned about right now, for rehydration or into the job that's persisted in Redis for later rehydration directly, quote unquote, without database accesses, except I'm wondering if that's not actually so much without. And so the deserialization process is leading to unexpected reads rather than something that's a little more targeted to only the things you're immediately loading in the job. Z, does that theory sound reasonable or bullshit to you?
So the good news is active deserializable appears to be something that is in this application and not a gem. So if we want to take a quick glance at it, I think that makes a lot of sense. But my guess is that, yeah, it's just a new concern. Yeah, it seems like it's not doing anything too exciting.
All right.
Yeah, it looks like it's just preventing deserialization errors from hammering the queue is what my read of that is.
Yeah. I do wonder still if the default deserialization behavior is leading to uncontrolled reads. I want to quickly check into that. The way I want to quickly check into that is seeing an instance of digest mailer job being set up so that I have an idea of how expensive the things it's serializing are.
Before we jump into that, I'm seeing this moment since followed by where not on line 14.
Ooh,
and that is very reminiscent of the same kind of query that's getting called by the moments controller index. And so that tells me that this is quite possibly a very expensive job to run. But that's an aside. I don't think we need to jump into that yet. We can definitely follow the path you were thinking, where we look into a use case of the digest mailer and then go from there.
I want to look into that. I also want to stick a note in because one thing I'm wondering about, Z, now that you've observed that, I want to follow through on your hypothesis about unique job or some other common to all jobs thing or shared code kind of thing is what causes the errors. But looking at this, I also do wonder, this isn't just an expensive query, it's expensive and an expensive query we've seen somewhere else. It's an expensive query of the kind that we're going to see a lot, like moment followed by since a given time. Those are all expensive. Followed by is going to involve some interesting multi-table joins, and depending on how you have your indexes set up, the time since query could be, let me just do a quick rule out.
So this is truly the heart of Notabli, right? Everything that we do is basically taking moments and segmenting them for a specific user. And in this case of the email digest, it's making sure that when I get 10 of the most recent emails or the most recent moments, that none that I posted are included.
Okay.
So maybe there's a better way to write that, but this is kind of everything we do.
I'm just going to do a quick sanity check of what since is doing, because my guess, Z, I promise I'm going to time box this hard.
No, it's fine. I'm doing the time boxing. You just follow your heart. I've got all the timekeeping on.
So since I want to look at the indexes on these, and I specifically want to look at the index on I don't know why the file finder isn't doing that. Maybe it's because it's ignored. I specifically want to look at moment.
My gut says that no matter how aggressively we index this, the complexity of the query is going to remain a problem. And in the olden days, back when we were running MySQL 3.x in production, we would create these view tables whose job was to basically observe writes to a particular table and then create a read-only representation of that table that was basically applied for a particular filter. So you'd have the view table for this particular user. And that way you could select all without having to do those multifaceted joins. And that's one way we could think about this. But yeah, so see here, we're like getting all the followed kids and all the private ones. And then it looks like I don't know what where any of is. Have you seen where any of before?
I have not. And where any of smells like it could get really expensive. I don't think we can alter that query right now.
Yeah, my gut tells me that changing the queries on anything is unnecessary. It seems like it is a resource contention issue that cascades out of control. And while these queries are really expensive and can cause locking, this feels way more like we have something that is tipping the cart over, right? And that is causing all these traditionally slow queries to just lock everything down.
Anyway, I followed up on the thing I wanted to follow up on. I just wanted to sanity check whether there was an index on the appropriate date field, because that can get really slow really fast if you're doing a scan on dates. And that's something that people often miss. But you are doing the reasonable thing there, so that's not low-hanging fruit. And
can you go show exactly how you saw that? Because I totally did not see that.
So,
Adam!
I really don't know why it doesn't. So when I was going through and scanning structure SQL, I went down to the indexes section. I looked for the moments indexes, and here we have create index moments on created at on moments using btree date created at. That is the appropriate index to have. That is an index that matches that query. That is an index that will prevent the scan I was worried about.
And that query is tied to created at, or are we assuming it?
And that query is tied to created at.
Okay.
And so, yeah. So.
All right.
My sanity check bore that things were sane, which is in some ways nice and in some ways frustrating. So let's go back to talking about unique jobs, and let's also keep on talking about deserialization, because, active job base. I want to see what we're serializing.
Are we on Rails 4 or Rails 5?
I think this is Rails 5, right, Jackson?
I believe so.
And the reason I want to see what we're serializing is that the default serialization for active job isn't to it isn't to. It doesn't serialize the entire thing. What it does is instead it pops off something called a global ID, which is a URI that combines the object's class, the object's ID, etc., and slings that into the database. And then it rehydrates using, guess what, database queries.
Yeah.
So if these things... Sorry, Z, you were saying?
Yeah, so to riff on that, global ID, the way... it's doing a single read of an ID from an ID. So while yes, that may be an issue, it's only going to be an issue if there's thousands of jobs being pulled at once. So I think that falls back to what you're talking about with improper batching of work. And that's, I agree with you that that's important, but I'm not sure that it's the problem, right? And we're kind of getting sidetracked in what I feel like is a more expository explaining mode and a little bit out of the let's solve this problem mode. So I'd like us to focus a little bit more in on I am trying to solve the problem and less on here's all these things that are happening, right? Because we can talk about all the things that are happening and that will that's like a 6-hour thing. Whereas solving the problem we can solve, even if we're going as quickly as we can, I get the feeling that solving this problem is going to be big, right? And so I'd like to kind of focus on that.
Cool. So unique job. Let's see what unique jobs even are. Sidekiq unique jobs. Who are you? Where are you coming from? Are you coming from Sidekiq directly? You might be coming from Sidekiq directly. You might be a Sidekiq feature. I don't know yet. Let's.
I think it's a gem if you pop open the gem file.
Cool.
It's also interesting. I'm just going to say that right now on line 17. There's this Sidekiq concurrency variable, which is setting the pool size explicitly to match this the environment variable for Sidekiq concurrency, which feels good to me. But that's just a thing that I noticed.
That is a good architecture decision. We might still be like making the pools too big, but that's a different problem. I do think that connection pooling is likely to be something we wind up resorting to today, but let's see. Or connection pool futzing with. So opening up the gem file. Sidekiq unique jobs, version 4.0.13. What do you do?
I mean, I could be snarky and say it creates unique jobs, but that's not super useful. Ooh, we are 2 major versions behind. That's exciting.
That might be an interesting knob we could twiddle. How is it locking? Is a locks from in the client. Okay, so there are multiple versions of locking. How is locking performed? Is it being performed in Redis or in the database? It makes a lot more sense for it to be performed in Redis, but I don't know that it is.
So look at that in a previous versions. So like, let's switch our tag to the 4.0 branch if we can, because I'm worried that reading the README for 6 is going to fill our heads with lies.
In previous versions, there was a default expiration of 30 minutes, which didn't work for a lot of long-running jobs. That's interesting to me. Although nothing I've seen here seems like it ought to be 30 minutes long. Several minutes long, yes, but 30 minutes, no. So that's interesting, but it's probably not useful.
Oh, so do you see that there's a link to the documentation for 4.0? Oh, too far. Oh, too far again. Very slow. 4.0.18. There it is.
Hooray!
Yay! Yes.
I'm just going to laugh at that for a second, but then move on with my life because while it is true and funny, it is not useful right now.
So
scheduled into Redis once. I still don't know where it's maintaining this.
So if we scroll down just a little bit further, my expectation is that the way it is locking is that it is storing it in Redis, but we can prove that by doing a little bit of investigation. But what I want to see is, do we have any calls to Sidekiq options unique : in our code base? Because if there's calls to Sidekiq options, then that tells me we're probably using this gem. And if so, we can find exactly where we are using this gem. I think you want Control-Shift-F. Interesting.
Okay.
So that looks like we're not configuring any particular gem to be unique. Can we check the Sidekiq initializer?
theoretically that should have caught it. And it does seem like it doesn't trigger unless you specify unique.
Unique
Okay, here we
until and while executing.
Until and while executing. Unique args first accept jobs ID. My assumption for how it ought to be doing this, which may or may not be how it is doing this, is that it's hashing the global IDs and doing a hash comparison, which would not hit the database, but I don't know that.
I mean, that is my best guess. It's what's happening as well. We're on Rails 4.2, which has the global IDs built into it. So my expectation is that it is, if we go back to that config initializer, is that if we could actually drop a console in there and be like rails.logger.info job ID and just kind of run a test on a job and see what happens. But my guess is that this is exactly what we need, right? Like it is removing jobs from the queue that are later than whose args are unique, and the global ID is what's coming in for the args, so everything is fine. So yeah, see that's all. Those are all Redis commands. Those keys *100 and del *100. So I doubt that the unique library is the thing that's causing the issue.
Yeah.
Another thing I've kind of noticed in the code base is there's a pattern of jobs delegating out to other properties. So if you go to the digest mailer job, there's this call to moment.sense, and then it calls the Mandrill email digest and calls dispatch there. And that dispatch method could be doing a bunch of writes as well, but it's unlikely. So my gut is telling me that my gut is telling me that it's not something that is shared across many jobs that is causing this to fall over. So I think we've explored our initial thing, and I think it's reasonable to decide that we don't have to, that it's not something that's shared across jobs. It's like something a little bit more.
We haven't.
I have some new information too.
New information?
Yeah. So when we were troubleshooting on the 26th, I just looked back through the logs and saw that Ty disabled the scheduler job for digest emails. So those digest emails have not been sending since then. And so therefore that is at least not causing, not the cause of this issue, not the root cause, that particular job.
So let's look at intercom update. So let's look at the intercom sync job, because that's the current worst problem child.
Well, it's been disabled, so it's no longer the worst problem child. But it is doing a lot, right? So it's interesting, like that. So however many users you have, like you're going to create all of these. Oh no, it's doing some batches. It's saying do it in batches of 50.
Yeah.
Well, but is it though? So what was the call to this?
It's from the intercom update job. Or intercom sync job, sorry. And
so create all.
From user.active. Create all, find in batches, so it is batching. It's not batching at the job level, it's batching at within a job level. And so this seems like the kind of thing that could trigger unique job. This seems like it's very much the kind of thing that could trigger unique's issues, because it's not getting, it doesn't look like it's receiving any arguments.
And I think we built this before the official intercom gem was available. So switching to that might also.
I don't know how unique jobs is going to parse argument-free jobs. I don't know if it's going to assume that each that none of them are unique, or if each of them is a specially unique snowflake. If it is doing the latter, then that's going to interact really, really badly with the structure of intercom sync create all, because while the batching strategy around find in batches is entirely appropriate for keeping it from thrashing the database, and keeping it from thrashing the database perspective, and keeping it from thrashing memory perspective, it is going to be slow. There are going to be, yeah.
I think I see where you're going with this.
Yeah.
But let's look at create, right? So self.create all is calling new, and then it's calling create, and create is going through and making 50 posts all within this one job, right? So this job could be taking that 30 minutes. It's doing 50 at a time. Yeah. So it's doing 50 at a time requests. You've got thousands of users, right, Jackson? Tens of thousands, billions. Call you Zuckerberg. Sorry. And what my gut says is you saw that thing about locks expiring at the 30-minute mark, and we were like, oh, but none of these jobs should take longer than 30 minutes. If we're doing thousands of HTTP requests to intercom, that tells me that it's possible that this job is failing pretty, like it tells me that this job might be having some issues. So I want to kind of think about that, but let's first chase down what you were bringing up. So if we go back to the Sidekiq initializer, the Sidekiq initializer has a lambda in it that says exactly how it decides whether a job is unique. args.first accept job ID. So that is pulling out that's pulling out a hash, and it is returning it back to unique args. And unique args, I'm assuming, is doing a comparison on both jobs for that. So if args.first accept job ID returns an empty hash in both cases, I would expect unique args the uniqueness check to be true. Does that make sense to you?
That makes perfect sense to me. And so this is going to be a prime candidate for running into the unique jobs comment about this does not cope well with long-running jobs.
Yeah. Jackson, you mentioned there's a unique jobs container that's filling up and not clearing a little while ago. Yes. That's in the configuration markdown file?
I believe so. I dropped the wiki to you just now.
I'm going to paste that into our browser real fast. Or I'm going to try and paste that real fast.
Mm-hmm.
All right. So that's interesting.
Okay, so you need to clear all the locks specifically.
That's what frees us up.
Okay. So
I don't necessarily fill up the locks though, because it's only locking the one thing, and there aren't going to be a significant number of different unique versions. There's only going to be the one version that's getting.
That is true, except for that thing that we saw early on, where it says something about locking in a previous version.
Yeah.
So previous versions, there was a default expiration, which didn't work. Since version 6, there'll be no expiration of any jobs. Please don't use lock expiration unless you really know what you're doing. So we might need to set the lock expiration to nil in Sidekiq in 4, so that the locks don't expire. Does that
Can I rephrase what I think your underlying theory here is?
Sure.
Because what you're saying doesn't immediately follow to me, and I want to make sure what I've back constructed for what I think you mean is correct.
Yeah, you can just go right ahead.
Cool. So what I'm hearing your conclusion as is, I said it doesn't make sense that for intercom updater to be filling up the locks because there's only going to be one lock present for it, just that on an empty hash. What you're asserting seems to be that because the lock expires at 30 minutes, there's going to be a new key inserted for a lock every 30 minutes if the job runs over 30 minutes.
It potentially could have a new key, right? You'd have to kick off another version. So this kind of brings us back to the the issue we were talking about before, where like maybe there is something that's at the configuration level. And I don't think it's the same one I was thinking earlier, where we were writing Postgres at the configuration level, but it feels like lock expiration. It feels like lock expiration could be a configuration level concern that would cause any of the jobs that take longer than 30 minutes, especially ones that kick off child jobs, to kind of do this kind of cascade thing, because the lock expires, quote unquote, and then a new one gets inserted, and we don't have any idea how many of those jobs are spinning off new jobs that take longer than 30 minutes or that kind of thing. Does that sound reasonable?
It does. To me, it seems weird that something that only added every 30 minutes would be causing this problem.
But keep in mind, some of these jobs spin out hundreds, if not thousands of jobs. So...
not the intercom updater, though.
So I think... I agree with you there, but there's so many background jobs in this system that, like, if we just keep going piece by piece by piece, trying to find the one quote-unquote job that's causing all these issues, I don't think we're going to find it, because it's tied to, you know, like in asynchronous programming, when you have a thing that does a thing and then spins off other things, and those things spin off other things, we're just going to be like jumping down all of these rabbit holes until, you know, my beard falls out from going old and gray. So I think there's got to be something in the communication side, and the concurrency pools could be it. This could be it, this lock expiration, so that jobs that are going slow and take longer than 30 minutes, and then a new job gets written into Redis, and that new job that gets written into Redis starts hitting the database, right? Like that feels closer to what's causing these cascades.
I hear what you're saying. I'm still skeptical. I think I have another way of articulating part of why I'm skeptical. And that might give us a path to validating either way. Which didn't work for a lot of long-running jobs. That doesn't talk about why it didn't work. Since version 6, there will be no expiration of any jobs from the default configuration, which implies that the problem that most people were experiencing wasn't that things weren't expiring fast enough, it was that they were expiring. Please, as is like followed up by, please don't use lock expiration unless you really know what you were doing. So like, I don't think that misconfigured lock expiration is going to cause things to fill up based on the way that they're phrasing that.
If a lock expires, then a new job can be created to take its place, and now you have two jobs. It's not that the lock disables that previous job, is my read.
Okay, so we were talking past each other a little bit, because I was assuming we were still going at this from the why are there so many locks being created that it fills up Redis. And you were coming at it from this ought to be locked because it ought to be locked uniquely, and so the new job shouldn't be creating. So now what I'm hearing is that you're asserting that when intercom sync fails midway through, which it's really going to if you are trying to sync that many users to the database, and make it the success or failure of the operation atomic. When it fails, we requeue it and we start the entire process of resyncing everyone all over again. And then we start that all over again and all over again, and we keep on running this, and lock expiration isn't getting in the way.
Yes, and because lock expiration isn't preventing these new jobs from being created, we could have, and we don't know how many background jobs follow that same pattern of do a bunch of things to a bunch of users all at once in a single job that could take forever. They're not forever, but a very long time. We don't have any real guarantee that we aren't accidentally queuing up some jobs that like fail and then retry and then fail and then retry. And then because Sidekiq does this incremental back off thing, like it's entirely possible that if we go back to Sidekiq and look at the stuff that's queued for retry, that those jobs might be the jobs that are super hella slow, right? Like they might take longer than 30 minutes and they might queue themselves up over and over and over again because they're not locked anymore. And then they just start at pseudo random times, not completely random times. And that gives us this pattern of massive writes. The massive writes start causing the system to start to fall over because it's, I'm trying to read and update stuff back and forth between some of these external services. And then as that happens, like we just start seeing stuff falling over more and more and more. Does that sound like a reasonable explanation, or am I just making random shit up?
I want a validation strategy for it because and like so like the reason I want a validation strategy for it and the reason I'm concerned is that I kind of feel like it could go either way. Like never expiring the locks on these could also have like other pathological effects is my concern.
Oh yeah, I think there's definitely the possibility for side effects that we don't anticipate, right? Like if it could be like, hey, this job is allegedly just for this time, and now, but the time wasn't in the serialized unique arguments or something. But my expectation is it is probably, it feels like this is safe to try. And we can also have Jackson, and I don't know if I can't hear Jackson. He might still be here. He might be muted. No, he's here.
I'm here.
But my expectation is if we try this, right, it'll take us a couple minutes to try it and get it committed in a branch. And then what we can do is we can deploy it independently, deploy that branch independently to production and see if it prevents the downtime at the very least. And if it starts preventing the downtime, then we can look for other side effects before we make additional changes. And we can also have a second branch queued up. So if it doesn't fix the downtime, we deploy that alternative branch where the configuration is, where we change something else. And we can, and that gives us the ability to try both without being committed to one and having a really safe revert strategy. Does that feel good?
That feels okay to me.
Okay. Because I agree, there could be some weird-ass stuff that we really don't understand and could cause some significant problems. So let's figure out how to set the lock expiration globally in the 4.0 version.
Yeah. That's why I keep on going, ooh, this doesn't sound good to me. So my concern, my proximate concern isn't like weird, unanticipated side effects. It's if we're not expiring locks and the locks are filling up, then that seems like it would exacerbate that problem rather than, like, it might fix other problems, but it would exacerbate another problem that is being observed, and it would exacerbate another problem that is being observed that seems connected to the downtime.
So I think what you're saying is locks filling up is I'm locking this particular record, and then I'm locking this particular record, and I'm locking this particular record. Like if we start the same job 3 times with the same arguments, you're expecting 3 locks to be created, right?
No.
Okay. So what do you mean when you say locks are filling up?
Jackson has mentioned several times that the unique jobs key space in Redis is getting so cluttered that things don't get through, and that clearing it.
You're talking about this.
Typically over several months.
Was that?
Typically over several months
of
time that it takes to fill up.
2 years ago. And you had a huge burst of activity in 2019, or to end of 2018, right?
Yeah, this is not up to date. This is like maybe when we first recognized this issue.
Okay, so it is a recurring issue, or?
Yes, recurring issue that I would say every 2 months or so I clear out the unique jobs.
Okay. Every 2 months is different than what I thought, so I'm fine now.
Okay.
If it was more frequent than that, I would have real concerns about what Z was saying.
Yeah, I mean, my gut also tells me that the container will fill up slower if we don't keep releasing the locks, right? If the locks don't expire, then it's not going to write as many of the locks to the system, is my gut. But I could be wrong. I'm assuming it's an item put operation, where it's like including the expiration time. So
No, seems reasonable. Thank you.
I'm going to try and drive, if that's okay.
Yeah.
And I want to start. So unfortunately I'm on push to talk. Do any of you hear the beautiful music behind me?
No.
Oh, it's so good. Anyway, you definitely when Maggie Tushman and children put out an album, it's going to be this amazing piano album, and you will love it. So I want to find the Sidekiq options. I want to find Sidekiq configuration for lock expiration in Sidekiq Unique Jobs 4. And I think I can do that. So here we are in Sidekiq Unique Jobs 4.0. Oh my goodness, my mouse is so sensitive. Slow down, buddy. README. And locking is hard. Sidekiq options. I'm just looking for expiration. That looks reasonable. Unique and while executed. You need a scope. The job would be unique for the number of seconds configured. Default 30 minutes, or until the job has been completed. And it will be unique for the shorter of the two.
Mm-hmm.
So if you want the unique job to stick around and even after it's been successfully processed, then just set unique until timeout. You can also control the expiration length of the uniqueness check. If you want to enforce uniqueness over a longer period of time than the default 30 minutes, then pass the number of seconds you want for the Sidekiq options. All right. So what I want to do is set this to a really, really big number. I don't know how to copy.
Mm-hmm.
That's not how you copy. And then I think, yeah, here we go. And so 60 seconds times 120 is that. That's 2 minutes. So this is hours. So 24 times 60, that's a day, right? In seconds.
Yes.
Can't we do cool stuff like 1.day.in seconds?
That's 10 minutes. Add another times 60 for seconds. Thank you.
I'm going to be super, super cool here. And I'm going to try and see if I can do 1.day.in seconds or 5.days.in seconds. Womp womp.
Two I will give you milliseconds, and then you can divide by 1,000.
I think milliseconds is. I think this is seconds, because there is a 2 milliseconds on integer.
That would not. That's way more than
I don't know how to spell. Is this how you spell it?
It's in versus 2. That's why.
Thank you.
I also had that moment of, but milliseconds is spelled correctly. Okay, so that's it in seconds.
All right, so I am going to set this to 5 days, and I'm also going to set the until timeout thing that they talked about, and we're going to commit this as a branch, and then we're going to hope to God that we can deploy this to Heroku after this session, and then what we'll do is we'll switch to investigating another possible solution and go from there. Does that sound good?
That sounds great to me. please include an explanatory comment that this means 5 days after the milliseconds number. Or you can do that. Thank you.
Yeah, I was gonna lean on my Rails because Rails is awesome. And then what was the other one? The until timeout.
Yeah.
Yes. Yeah. If you want it to stick around even after it's been successfully processed, then set unique until run. I don't think we want that. I think we
until and while executing. I think is what we want.
Yeah. So, and there's a run lock. Control the expiration length and the runtime uniqueness. If you want to enforce uniqueness over a longer period than the default 60 seconds, you can pass the number of seconds you want to use to the Sidekiq options.
I think messing with that default sounds dangerous to me.
Well, but the problem is we do want it to remain unique while it's executing, right? So we don't want another job to be kicked off just because this, 3-day long Sidekiq magic sinker job started. So I kind of want to make this 1 day. Does that sound healthy and safe, or do you think that's a terrible idea?
I work through it in my head. I'm going to feel more comfortable with it if we make it a spot thing on the problem children, but I understand your concerns about trying to identify unique problem children. My concern, I think, is probably irrelevant because it's saying specifically run lock. But my concern is that will make, I think we're fine.
Yeah,
I wanted to make sure we weren't actually. I wanted to make sure that it wasn't doing anything that would have a paradoxical side effect of making it harder for things to be meaningfully unique because that would lead to a lot of repeat jobs.
Yeah, I agree with you there. I think we're probably fine. And again, it's safe to try. We can look at it, and then Jackson. Oh, we lost Jackson.
In my head.
Come back, Jackson. Help us.
Hi.
Oh, so Jackson. One thing to keep in mind, as Betsy was just saying, is when we push this, you might notice a change in user behavior. And quote unquote user behavior, right? In the sense that they may not be getting all of the events that they used to be getting because we're adding these timeouts and these locks and stuff like that. Is that a reasonable rephrase of what you're saying?
Yeah.
So I don't know if you have you have intercom.
Yes. It's going to be tough. I'll tell you that because there's a lot that goes through these background jobs.
Yeah.
So, and some of them are not, really clear if something is successful or not, like adding a photo to a photo book, which is pretty important because people are paying for these books that get shipped out to them. And so it's hard for us to know if that photo is ending up in the right place at the right time.
Yeah, that's an observability issue that I think we might want to consider making possible to look into in the future. Once we stop the bleeding, of course, the stopping the bleeding, I feel is the most important thing.
And currently we're coming up on 2:30. I want to briefly talk about connection pooling, and make sure that we know how to do that. It looks like it's a fairly simple, or know how to change the connection pooling downward. That looks like a fairly simple environment variable change. And then after we look into that, I'd like to talk about broader architectural patterns we're noticing. We've already been doing that, but turn that into something like actionable advice for the Notabli team to perhaps follow up on during the next 2 weeks.
Yeah, I'm on board with that. So I'm gonna check out this branch, commit it, and then I'm gonna check out this branch, add this, commit it, push it up so CI starts because I have no idea if this will actually work from a config perspective. And then and as soon as that's done, we'll switch to you driving and investigating the connection pools. Sound good?
Sounds great.
How do you go back a line?
In Nano, manually. Or if there's a better way, I don't know it. It's pretty minimal in terms of key bindings.
All right. Well, I'm willing to consider this a decent commit message. Betsy, do you have stronger feels about this?
Nah, it'll be fine.
I get pushed down, and it gets up again. Anyway, Chumbawamba just goes through my head all the time when we're doing this, and I thought I should inflict that upon you as well. Anyway. All right, Betsy.
You let's karaoke, and you know that it is unironically my favorite karaoke song.
All right. Yeah, I at some point in the future, I do want to record my Coding the Distance parody, and I think we could also do a Chumbawamba, it gets knocked down and gets back up again parody specifically for this series. It's gonna happen. It's gonna happen. All right, so I'm done. I've shipped my bug fix attempt. Betsy, do you want to take over around connection pooling?
Sure. And this one I think is going to be relatively quick. I want to verify that our guess as to what this is doing was correct. And then I want to, I don't think it's appropriate for us to look into it in the database, or in the production app, because that would involve exposing your general configuration variables to the broad internet, and I am not comfortable doing so.
Jackson, could you look it up?
Yeah.
And let us know what that number is?
Yeah, sure. What am I looking for? I might need some guidance.
The Sidekiq concurrency environment variable in production.
And in the meantime, we might want to look up and verify that the pool...
Yeah, that was what I was thinking. We need to make sure that the pool query bit is actually doing what we think it does, namely control the number of database connections allowed in RDS.
And the other weird thing that I just noticed is we are setting a variable called connection URL, and then we're setting another variable inside of an if block, and then we're just calling established connection, and I have almost no faith that the established connection call is functioning the way we think it is.
So db_pool, is that one that you're looking for?
Looking for Sidekiq concurrency.
1.
Okay, so that number being low might be bad, because what that's saying is for every single Sidekiq worker, it is giving one independent pool. And so every time we've decreased that number, it might have increased the amount of problems because we have so many more connections.
Maybe. That doesn't make sense to me, see? I mean... Oh, here is an interesting one. Dev Center, this is in response to a specific thing. Let's look up what's going on there. That will probably give us a much more precise bit of information than Googling randomly around.
Yeah.
I'm
so excited that we learned how to copy and paste. That is really my biggest takeaway from our first session, is how to copy and paste.
To prevent sharing of connections. Huh.
Each fork will receive its own database connection pool. For this reason, most applications using fork-based web servers receive the best performance when the application level, for example, Rails, SQL, or Django connection pools, is not used, or is used with a pool size of 1.
This is really weird to me, because this was not my previous understanding of Sidekiq. I think maybe it has different stuff around it seems bizarre to me, but it must have different stuff around HTTP connection pooling than around database connection pooling, because my previous understanding was very much not this.
So by default, there's 25 threads per process. So, or no, are there 25 threads or are there 25 forks? I get a little confused between what a real thread is and what a thread is not in Ruby.
Okay, so that's interesting, right? Because like it was previously saying it's a problem in Sidekiq. Okay, so this has nothing to do with forking per se. It's just included in here because it's going to be a similar kind of concurrency problem, I think.
Yes.
Okay.
But it looks like what it's saying is that Sidekiq shares the same pool so long as you do the established connection in the initializer like we're doing.
Sidekiq server, yes, its own connections, cleaning up and reestablishing connections in a So Z, if I'm hearing what you were saying earlier, the thing you were concerned about this being one is the implication that Sidekiq is not using a cross-thread connection pool and instead is spawning a new connection per worker.
That feels possible. Well, I would expect that it would have a pool per worker. But I'm guessing that it has many workers. Like the thing I'm having a hard time wrapping my head around is what's a worker and what's a thread and what's set for what in Sidekiq.
My understanding of how Sidekiq handles this, which may be incorrect, and we can validate this, but my understanding is that a worker is equivalent to a Sidekiq process, and each process has several threads within it. My understanding of Sidekiq is that it maintains a single connection pool at a per process level, and so all of the threads would share a process.
So 5 workers in a process, and each worker has 5 threads, and so you have 25 total jobs processed per X period of time, but they're all using the same connection pool. Is that what you're saying, or am I misunderstanding?
Kind of. So I want to get away from using worker because I think right now it's not a useful. I think it's a term that's adding more hate than light. Per Sidekiq process, there are like, let's pick a number, let's say 25 threads and one connection pool, which contains a number of connections that is equivalent to probably the Sidekiq concurrency variable, but we don't know that. My understanding of how Sidekiq handles connection pooling is that all threads within a process will draw from the same connection pool. So if there are, let's say, 5 connections in the pool and 25 threads, then each thread will pick up a job, begin to execute it, and block until a pool connection is found, which if you have 5 connections and 25 threads is going to be, you're going to spend a lot of time blocked on that, whatever, those are random numbers. But to me, that understanding excludes your hypothesis, which is that each Sidekiq job is spawning up its own connection pool and therefore is thrashing the database with new connections.
Okay, so let's pretend that we have our Sidekiq concurrency is set to 1, and if we look at our proc file, we can probably see what Sidekiq is being launched with. But the Rails threads are probably set to some other number. Do you see like a Rails concurrency or any other concurrency configurations, Jackson?
Checking.
We can also Command Shift or Control Shift F and search for concurrency.
Web concurrency is 4.
Okay, so web concurrency I expect is being used by Puma to figure out how many threads Puma is doing. Sidekiq concurrency is probably being set by something else. What's this DB pool and max threads stuff?
And this is going to be for each Puma process.
DB pool is set to 30.
Okay, so whenever a Puma process restarts, which is going to happen whenever it's hit by the Puma worker killer, that's going to be making 30 new connections on startup.
And I bet every time Sidekiq starts, it's going to do the same thing. Because that pool being set in the URL, I don't think that does squat. Like, it might, but I doubt it.
That's probably right. I don't think that Sidekiq is starting that often, though. It doesn't seem like the Sidekiq worker is restarting that often.
Yeah, that's fair. So what you're saying is Sidekiq, the process, starts. Puma, the process, starts. Both of those grab 30 connections per process. And we have one process per dyno? Or is it one process, or is it multiple processes per dyno because of our Sidekiq concurrency and our web concurrency? Or am I just...
And we have one dyno currently for worker.
Okay.
I think that connection pooling is a red herring. I was really excited about it earlier, but the numbers I'm seeing compared with the config I'm seeing, to me, really strongly implies that connections being rapidly established is orthogonal to Sidekiq and really only has to do with the Puma issues.
But remember in the last session, I mentioned how the Heroku automatic restarts preceded these spikes in H12s?
Yeah, you're right.
So it could be it's not the Sidekiq pooling that's the problem. It could be the web pooling.
The web pooling, like 30, 30, 30, 30.
Yeah, I think that it's establishing all of those really fast, and that's also bumping our number of IOPS at a time when we can't afford it.
And if we get to out-of-memory issues, then it's starting that over, right?
Yeah, exactly. That's why I was saying
that just cascades.
Related. Yeah, and so I think that that's a contributor to the cascading because it's radically spiking IOPS.
Yep.
Especially because at the same time, Rails is going to be reestablishing its query cache because that is going to fall out of memory. And so I think the restarts plus Sidekiq are a problem.
That makes a lot of sense to me.
I think that bumping this number down and VD pool, which is 30, is going to have an ameliorating effect.
You said DB pool is 30 or web pool is 30?
DB pool is 30.
Do we know when that was last changed?
I don't know.
Okay.
I don't remember discussing this, so it probably, maybe it's never changed. I don't know.
I think it's going to have a pretty dramatic effect. My theory of what's going on, of what will happen then, is that Rails is starting up on a new Puma process after each kill. It's initializing 30 connections, which is already creating a little bit of strain, but which isn't that bad. But then it needs to also reinitialize its database cache when requests start coming in. And that is going to mean that a vast number of reads go shooting out through all of those 30 connections for each of these 4 Pumas. So all of these 120 connections. And that's a lot of reads at the same time as we've got all of these writes. And so boom, IOPS spike. We're very sad now.
So why would we have set DB pool that high? And are we going to potentially lose anything by reducing it?
We are going to lose things. We're going to lose overall throughput. That number of DB connections means that the number of requests that Puma can service at any given time is a lot higher, because when Puma is servicing a request, it's going to block waiting for a database connection to come available out of the pool. It's that same thing that Z and I were talking about earlier in the context of Sidekiq. If you have 25 threads spun up to service, in that case, jobs, in this case, requests, and each of those threads is using the same 5 connection pool, then you're going to have 20 threads sitting around waiting for other resources to free up a lot of the time. And so my guess is that it's that high because under less pathological conditions, you really wanted the request throughput that having a relatively high number of database connections at a time can give you. I think right now it's not great. I think what I'm proposing is not a long-term solution. And I want to be really clear about that. I think this is a stop the bleeding solution so that we can also enable better architectural practices like batching jobs or batching within jobs. Because right now, that job batching is the root cause, but we can't fix that in another half hour. We can just go, oh God, that's a problem. Okay,
so what I'm hearing you say is, Puma worker killers are maybe killing killing a Puma thread or process or whatever. That Puma thread is falling over, and sometimes it's not releasing its connection, and then a new Puma thread gets started to replace it, and we see this creeping of the amount of pools. Because the way that connection pools work in Active Record, according to my very scattered history, is it allocates a new connection if it feels constrained, right? So if it's not feeling constrained, it's not going to allocate a new connection from the pool. And so what's happening is these connections are kind of like inching up. We hit the maximum, see this peak here, this plateau? That feels like the maximum amount of connections AWS will even let you have. And I'm willing to bet that these are caused by Puma killing itself. And then because Puma killed itself, it reconnected, like you were saying, and it really aggressively did it, and it never lost its previous connections. And the dropping and the resetting of the database, what that does is it cleans out all those gross, stale pool connections and allows it to keep going again. So if we do the stop the bleeding suggestion, we can drop our DB pool down to say 10, which is a third, and we can see if we even if we have 10 and we have four concurrencies and 2 dynos, that's 2 times 4 times 10. That's still 80 connections plus however many connections come through Sidekiq, right?
Did you say 4 dynos? 4 web dynos?
Two dynos, 4 web concurrency, 10.
We have 4 web dynos currently.
Okay.
I'm sorry. Let me just confirm that. I might be saying the wrong thing. No, we have 6 web dynos currently.
Okay. So Betsy, can we figure out exactly what your concrete proposal is then that we try?
My concrete proposal is bumping database pool down. My contention is that this will increase stability but reduce throughput. I think because it will reduce throughput, it's a temporary measure to get stability up while we fix the root causes of the stability issue. I think this is a contributing factor, but we wouldn't need to be doing it if other contributing factors that we can't fix in 15 minutes weren't also present.
Yeah, and I'm just reading some tea leaves here, but the requests per second aren't that huge. Like we're looking at 200 to 300.
Okay, so you think it's just going to be fine if we bump it down and the throughput goes down?
I don't think it'll be fine.
What's your time window there?
This is every.
Because this is early in the morning.
Sure. So let's go back to here. So at our peak, we're seeing about 1.1K requests per second. And our dyno load at our peak is still gets kind of brutal.
Now, is it true that if our dyno load is like 1.2, 1.4, less than 2, do we need 6 dynos? Or have we been throwing money at the wrong thing? Or
It's
is that
possible
not something you
that
could
you-
answer?
Yeah, I think we'd have to read more tea leaves, and I don't think we have time for that today. I think I agree that what we can do is do an incremental back down of that concurrency number, Betsy. We could do something like drop it to 20 instead of 30 and see if that alleviates the issue and if it hurts the throughput too badly. Does that sound reasonable?
That sounds reasonable.
What would I see on throughput being hurt? What would be the symptoms of that issue?
So right now you've got this very spiky request timeout pattern where requests are normally pretty performant and not happening at terribly long times, but occasionally you'll see these spikes of, oh my God, everything is wrong.
Yep.
My belief is that this will possibly slightly bump up the average request time, so the 50th percentile request time, but it will really flatten out these spikes in the 95th percentile request time that cause everything to fall over, or bump, or make, not eliminate, but make the 95th percentile spikes a lot.
Could we record? So should we write down what these 7-day averages are that we're looking to?
That would be great.
Or we could screenshot that or something if we're on the right window.
Yeah, I can't screenshot it because it keeps screwing up my VNC connection.
Here,
if you screenshot this, that would be useful. So this is the past 7 days.
Okay.
Yeah. And these spikes, that's all your downtime, right? Like when the system falls over and you had to reboot stuff, that's what those spikes are.
Yep.
So it's not super useful. Here's the... I think this is the mean response time, which is a little bit more useful.
Like my best guess is overall a little bit slower, but much smoothed out.
So this also, I don't want to conflate the issue, and maybe this will or won't, but also it seemed like we have these issues, but they were clearly exacerbated by holiday traffic, right?
Yeah.
So is that because the more throughput, we were getting more memory max, like out of memory issues?
Maybe.
It doesn't feel like a memory allocation issue.
Yeah, like I think you've got a memory leak because if you didn't have a memory leak, you wouldn't be having so many Puma kills. But that seems like it's small potatoes compared to the cascading Sidekiq issues.
Yes. And I'm thinking that when we were looking at that RDS sheet and that monitoring of the last 7 days or so, and Z mentioned the plateaus, that before there was one spike that went up higher. That was probably before we reduced the concurrency, correct? Would a higher concurrency allow it to go higher connections?
Yeah.
Well,
that one. Like, why did that not plateau?
My gut tells me AWS is being nice to you.
Or is that's not related to, looks like the time when we changed the concurrency?
I think you must be right about it being AWS plateauing, because if it's 30 per connection and there are 6, or if it's 30 per Puma and there are 6 Pumas, then that's 180, and 180 is much lower than 120, or much higher than 120.
I mean, I think I see what you're driving at, Jackson. I think what you're saying is we can establish more connections and it's not that big of a deal, right? Like if we go to our, if we have seen more connections come in, and these more connections have came in and things have been kind of okay but not great, and that hasn't seemed to have been the issue. The fact that it's plateauing now is possibly an indication of 4 times 3 times whatever gets you 120, or 4 times or 6 times whatever times 30 gets you 120, and then these 122 are the Sidekiq concurrency or something, right? So Jackson's asserting that we can actually handle more at AWS's side, and the connection pooling, like, decreasing the connections per pool might help, but may not actually solve the problem because we can get more connections in the past.
No, I mean, that all makes sense.
I don't, if we had 4 Pumas, then the math on that would make sense. We have 6.
So what are we looking at? I mean, can you break this down for me and other people who might not know specifically? But like,
here is
when 6 Pumas, is 1 Puma equivalent to 1 worker or one web dyno?
Yeah, 1 Puma is equivalent to 1 web dyno.
Okay.
And each of those is going to have up to 30 connections.
Got it.
And so what we see here is this spike is maxing out all of those plus the Sidekiq workers. So 6 times 30 is 180 plus 2 for Sidekiq.
Okay. So, and we were seeing issues as early as like 80 connections.
Yeah. I don't think it's the raw number of connections that's the issue.
Okay.
I think that it's a lot of connections being established at once and a lot of data being slurped down those connections. And my belief is that that corresponds to Puma restarts. When Puma restarts, all of its previous connections go away and it needs to reestablish them. It also needs to reestablish its query cache, which is an in-memory store of frequently accessed queries that goes away when it restarts. And so you have a lot more, you are going through the IOPS load of establishing connections, and B, you're going through the significant IOPS load of slurping a lot of data down those freshly established connections because it was in memory in each Puma, and now it's not.
Yeah, you'll often hear this described as warming up the cache, right? So a lot of infrastructure strategies are, if you're going to add a new server to your pool, you will you'll start streaming requests to it in simultaneity with another system, but you're not going to actually send its responses back to the client. You're going to let your existing servers handle those responses for about 5 or so minutes. And then once it's warmed up its cache and it's pulled all the data out of the database that it needs to process those requests, it can start doing more fancy things. The other issue is, I think caching is really hard in your database schema because you're doing really complicated, really unique queries. And so if we want to really solve this problem, we need to restructure the database table, the database schema, such that it's easy to pull a list of moments and filter those without doing a bunch of joins. And I think we can get there, but I think that's a new season of like, how do we refactor to improve the read performance of a PostgreSQL database that, has all these stuff going to it.
Sure.
All right,
okay, so thanks for that explanation.
Yeah, no problem. Thank you for pushing for it.
Yeah. And so we have about 7 minutes left. I think we have 2 next steps that the Notabli team can take. One of them is they can deploy my beautiful, beautiful branch that may be completely unnecessary that changes the Sidekiq locking.
Should we hold off on that one? Just because there's some concern? Like maybe we hold off on that and see if this makes a difference first. Would you agree?
Yeah. Yes, okay. I agree. And then the other next step is to do the pool, change the DB pool down. And I think, and this, Betsy, tell me I'm a terrible person and this is a terrible idea. I think we should also increase the Sidekiq concurrency a little bit so that you can have more connection pools in Sidekiq as well. Because right now, Sidekiq's getting a single connection and doing all of its work through there, and that's going to make your Sidekiq jobs go really, really slow because they're just waiting for access to that resource, right? It's like the classic dining philosopher's problem.
That sounds reasonable to me. I do think, ironically, that we're going to see fewer database thrashes if Sidekiq is allowed to do things, because there might also be some timeouts going on Sidekiq's end that are causing retries. Right now, a lot of the work of the application is in Sidekiq, and we're giving it 1 or 2 connections to the database, and then we have 180 potential connections. It's mainly only 120 to 60 to 120 at once, but 2 to 60. That seems unbalanced.
Yeah.
Yes.
And so in order to do that, what we need to change, if I'm gonna pull back Adam.
Mm-hmm.
We need to change the DB pool to a lower number And then we need to change the
Sidekiq concurrency.
the Sidekiq concurrency to a larger number, and hopefully what that'll do is bring balance to the force of the workers and the webbers, and make them play nicely together.
What do you suggest for Sidekiq concurrency? 2?
No more than 5, certainly. This is something we want to bump up slowly.
So what's your suggestion?
2, and if it seems to help, keep on bumping it up to 5.
And do you think we should do this at the same time as decreasing the database pool to 20?
Yes, you should do it after you do that.
Okay.
Yeah.
Like after, as in like just after, or after we see what database pool has an effect?
After, as in just after.
Okay.
My concern isn't waiting for effect. My concern is that bumping up the Sidekiq concurrency when we're already having a problem with hitting our max connections is just going to make things worse. So we want to bring things down to make room to bump up the Sidekiq concurrency before we bump up the Sidekiq concurrency.
And when I make these changes to the variables, these config variables, does that restart the app?
Yes.
So each time I'll do database pool to 20, it'll restart automatically, and then I go right back in and change it to Sidekiq concurrency from 1 to 2.
Which will be expensive, and so maybe like wait. Actually, no, like restart right after, because my first instinct was wait like 30 minutes between restarts, but I actually think that since restarts are going to be painful, you might as well just do it fast.
Okay.
Yeah. You can also turn on maintenance mode. Like you can pick a maintenance window essentially and turn on maintenance mode and increase and change both of those numbers and turn maintenance mode off, and that'll allow them both to refill their cache. The one issue I would be concerned about is like turning on maintenance window mode does not stop your workers, so you need to turn off the workers as well. Like remember how you have to switch and turn that off?
Turn on maintenance mode and then reduce all the workers and all the dynos down to 0. Then make these config changes, then ramp up the dynos, then turn on off maintenance mode.
Yep. And the other thing to think about is right now you're hitting 25 to 46% of your memory usage on your dynos, your background worker. So if you do 5 for Sidekiq concurrency, I would expect that would multiply by 5, Betsy, or would that multiply by a smaller number because of the shared stuff in memory?
Can you repeat that, Z?
So the memory usage right now is at 25%. So if we increase Sidekiq concurrency to 5, is that going to multiply the memory usage by 5, or is it going to multiply by a smaller number?
I think by a smaller number, but I want to see where else Sidekiq concurrency is used as an environment variable before I keep on looking at that.
Looks like it is only here in these 2 spots.
Great. I think it is going okay. Yeah, don't bump it up to 5. So
I was going to start with 2.
Yeah,
this seems very odd to me. I don't really understand why the connection pool size is tied to the. Oh no! Now I get it. It's tied. So it's saying. Ooh,
it's saying it wants a pool for each concurrent thread. Yeah,
and that makes or a connection to the pool for each concurrent thread, which makes perfect sense. I'm fine now. So don't bump it up by more than 4. I would do 2 or 3.
Okay, and we're fine with 1 worker dyno.
Yeah,
and we're fine with 1 worker dyno.
What I would suggest is bump concurrency up by 1, see how your memory usage changes over the period of a day, and then possibly bump it up by however many you think are comfortable given that memory usage change. So if you're hitting 60 or 70% memory usage, don't increase the number. But if you're at 30% memory usage over the past day, you can probably try and increase it yet again and increase it yet again. And do it day by day by day. And hopefully, assuming you're not going down all the time, hopefully that'll be a safe possibility.
And then if this all looks good, we could probably try turning back on the intercom job and see what happens.
Yeah.
Yeah,
Yeah.
I still
It
I
still
still
does need
think
to
it's
be
dangerous.
restructured. And so some quick, off the top of my head, thoughts for restructuring it.
We're at 3
Right now,
o'clock,
the
by the way,
thank you.
so I don't want us to dive into anything new just yet.
Fair enough. We will either talk offline or during the next session about things we can do to make this job better. But right now, it is doing too many things and can be restructured just to hit the database significantly less.
And maybe we could use the official gem.
That might help.
That is likely to help. It is probably not going to do everything.
Yeah. Because the gem, unless the gem has built-in batching that works with active job, then it's probably not going to do anything magical for us. Cool.
Great.
Well, thank you everyone for showing up and participating and helping us figure this out. And I will probably get this uncut and aligned and maybe a tiny bit of like background noise cleanup and overlap cleaned and pushed onto YouTube probably in a week. And Betsy is literally out of the country for the next month. So if we want to do another session, we'll have to change it off of Tuesday, and we can either pull in Jennifer to kind of help out with this, or I need to think about who I could grab to pair. I might do a call for, like, maybe Avdi would be interested in joining. I don't know.
Yeah, that might be
and
really
go from there.
But yeah, at this time in 2 weeks, I am going to be somewhere over the Pacific Ocean. So probably not the best for a video call.
Well, enjoy your trip.
Thank you.
All right. Thanks, everybody.
Thanks,
I will
both.
see you all later.
See ya.
Bye.